All right, hello and welcome again from my side. I'm Benjamin. I work for EODC, and in the C-Skill project, I'm caring about OpenEO platform and also about user requirements and the use cases. We are going to do a basic training today. For some of you, as I have seen, are quite experienced in Earth observation, because I know you partly, but nevertheless, I would ask you to use any device, or I will quickly just share this link into the chat. Just give us a quick notification about how what we can expect from you, what experience level we can expect. Actually, I can run through the slides a bit faster or slower, or whatever. Exactly, that's the background of this. Let's see, I can just click the link here, so open this up. And this is actually, no, I can see the answers here. Till now, we don't have any answers. It's just 3 questions, so should be really quick. And I think you can select multiple here. Here we go. The first answers are in here. So we are 2, 4, 6, 2, 4, 6, 12. All right, we should have gotten around 8 answers by now. Yeah, I think that should be fine.
Just one thing in question 2, I think you can only select one answer, and I think, like, for me, it would have been pretty much
all of them. Yeah, okay, perfect. Yeah, that's fine to us. Do I really need to use OpenEO in my work? For very experienced people, it's a good question, actually, I would say. Anyhow, I will run through the basic training here really quick, or to the basic introduction, do the basic introduction really quick anyways, to just give you an insight what background OpenEO platform has. So in the end, we provide with OpenEO platform an intuitive programming library to process a wide variety of Earth observation datasets. Basically, currently are 115 collections on the platform, and currently supported by 3 backends. But there are other backends around. You can check these on openeo.org. Just exactly on that website, you will find information about the running backends, whereas OpenEO platform has joined forces of 3 of them, EODC, Veto, and Synergize with the Sentinel Hub backend. Basically, it lets you run the Earth observation analysis on the federated infrastructure of EODC, Veto, and Synergize, exactly. So why do we need OpenEO? Probably some of you have seen this slide. So in a traditional remote sensing way, you as a researcher or myself as a researcher identifies their study area. Then you search for the Sentinel-2 level 1C collection because you are interested in optical data. Then you download all the files and you start to care about them. Then you use send to core or force to pre-process these files to level 2A. If you want to use force, for instance, you really need to do that because the level 2A from ESA is not a force product. Then you need to resample or do whatever you like to a target resolution and create a subset in space and time. And then you realize at some stage, oh, damn, my network storage is full and I need to ask my university or my provider for more network storage. So OpenEO is basically there to take care of all steps from 1 till 6, I would say. You still need to define your algorithm, and then you can do a fairly easy analysis on the platform. The situation before OpenEO is basically this, that you have the Google Earth Engine users using Google Earth Engine. Just let me get out the laser pointer. You have Sentinel Hub users using AWS in the background. You have the Veto Cloud users, and on EODC, you have EODC users. So what happened with this OpenEO API, with this common language, is that you actually can define your Earth observation analysis and run it on various backends. So basically, it has been proven also that you could define something in OpenEO API and run it on Google Earth Engine, for instance. Or you define the same analysis also runs on various backends. That's the background of OpenEO. And that was actually the Horizon 2020 project, which was led by TU Wien. And then after the Horizon project, these 3 backend providers went on to add this aggregation layer in the end. So you have an additional aggregation layer so that the user doesn't need to define the specific backend where to run the Earth observation analysis, but only communicates with this platform layer, so basically an aggregator or federator, and the analysis runs underneath that aggregation layer and runs on the various backends. Exactly. So since you're all familiar with data cubes, I'm just gonna run very quickly through these concepts because you all are aware, I'm pretty sure. So data cubes are multidimensional arrays with one or more spatial or temporal resolution, and OpenEO basically, any data that is represented in OpenEO is represented in these data cube structures. You can look at a data cube like this, but you can also look at a data cube like this. Exactly, then quickly explained, we have various dimensions in the data sets. These dimensions usually have a resolution or a couple of bands or a time resolution, right? And what you really need to be careful with is the dimensions and your coordinate reference system. So when you change the data types of these dimensions, have a look if the backend really supports this. Exactly. So obviously, very obviously, OpenEO supports this filtering on data cubes. So you can filter on temporal, you can filter on bands, you can filter spatially, and then only if the condition is only the data is only returned if it satisfies the condition that you give into these filters. Very basic concept as well is the apply process. So you can do data manipulation over kernels or neighborhoods and do spatial and temporal smoothing with this. Here you see a smoothing algorithm in a spatial dimension, and I think the top one is temporal smoothing, exactly. Spatial and temporal up and down sampling is obviously also supported. So if you have an input in certain temporal time frame, you can up sample or down sample this based on certain conditions. Same applies obviously also to spatial up and down sampling. Exactly. Then here also concept is the reduced dimension function. I would go into more details if necessary. So just if you're interested in more details of these functionalities, just let me know. So the reduced dimension function basically collapses one dimension. So you have to give it a reduced function, a mean, a max, a min, a median or so. And then you collapse basically this dimension alongside this function. Exactly, the aggregate spatial and temporal is also very known in the GIS world. I don't need to dive deeper into that. For you, maybe more important what has been done on the platform, and I wanted to point out two use cases that actually come from the community, so are not use cases from OpenEO platform. I will show you later two use cases from the platform in a live demo. But here, basically, what has been proven on the Living Planet Symposium user consultation is that you can use a user-defined function and implement this into OpenEO, and you can analyze based on Sentinel-1 signal disturbance features selective logging sites from the Central African Republic. So this is actually also a C-scale use case, but for C-scale, I think it's about the Amazon basin, so it's the return use case, and here it has been proven that this also works in Central Africa. And you basically analyze the magnitude of the Sentinel-1 signal disturbance, and then you can say, okay, this is a selective logging site. The other use case that we have seen is a use case from the community, basically with the river discharge. So you can see these sand banks alongside the river, and these correspond really well to river discharge. So you can use the Sentinel-2 imagery, and this has been proven actually worldwide. So on some, or not worldwide, but in North America and in Europe. So you can see that these local data correspond quite well with the OpenEO cloud data and the river discharge that has been analyzed. All right, the other part that you might be interested in is a very active user community. So basically what you can see here, these users that have done these use cases have asked a lot of questions on the forum as well. And so these forum articles are usually answered by our developers, and then you can just get insight on what is happening, or what do I need to do, or how can I apply such a functionality or something like that. And then you're informed, hey, this is possible, and so on and so forth. So in the end, you can basically represent your Earth observation analysis in a common language, and the analysis that you are defining, and this is the great part about OpenEO, can be defined with any available client package. So I'm gonna open my browser again, and the available client packages can be seen here. So if you go down here, so we have 3 clients, the Python client, the R client, and the JavaScript client. And also available is the Jupyter Lab, where you can use the Python interface to actually define your analysis. In short, I'm going to show you exactly this. So I'm going to use the Jupyter Lab. And the other option is to use the OpenEO platform editor. So basically, it's a very simplistic option to define an Earth observation analysis. So you have all your collections here, and similarly to LabVIEW or other drag and drop packages, you can basically drag and drop your collection and also your processes in here, so you can do your analysis by connecting these together. So for instance, this is actually wrong, I need an apply for that, but I think there's even an NDVI, for instance. So here there's an NDVI process, so I would just drag and drop and do a save result in the end, and then I have a full running Earth observation analysis already. Just need to define the format, the output format, exactly. So I'm gonna quickly, I'm not gonna dive deeper into this visual representation of an Earth observation analysis here, but it's for basic users. It's very useful to also be able to see or to use this interface. Yes, maybe quickly another last point. So where can you find help? So OpenEO.cloud is the first address to go to. There's also a documentation page available on docs.openeo.cloud, and I have already shared with you the openeo.org. This is basically the predecessor project, exactly. And if you have any questions, the forum is also helpful. All right, are there any questions until now? Can you still hear me, Sebastian? Just
yes,
say.
I can hear you. I'm looking at the chat, and I think Bernhard wants to say something.
Okay, go ahead.
Well, I just said yes, I can hear you.
Oh, perfect.
But I don't have a question just yet. When we are in the workflow, I think.
Okay, perfect. Yeah, I think I will just then go to OpenEO Cloud, and sorry that you have to look at my profile right now, but I'll just start doing the analysis now. So if you go to OpenEO Cloud and click on the Jupyter Lab, what you will not see is this, but if I go to a private window, this will actually show you what you will see. So you will end up on an I have a private window open, which I used before, so this doesn't work either. Let's open a Google Chrome private window. I'm really sorry. Exactly, perfect. So if you go to OpenEO.cloud, and then you go to the Jupyter Lab, you will end up with the EO Lab sign-in page. This EO Lab sign-in page allows you to select two options. It's either the EODC identity providers or the OpenEO platform. What you will use later is the OpenEO platform option. And after that, if I click on here, you will end up with an EGI check-in authentication page. I'll give you for the next week, all of you, I will give trial accounts. So that means you can, over the course of the next week, you can just go here and test it yourself. And just try out things. And if you need a second week, just let me know, then I won't change your password, and that's all fine. So what you will do is you will go to EGI SSO, then you type in the test, account later on, and then I have the passwords somewhere, just a second. Yeah, I got them here. And I'll give you the passwords later. Then you need to quickly accept here and that you share the dummy files and so on. Then you can start an OpenEO platform lab, and this should be a dummy lab where you basically get an empty workspace on EODC. Actually, this one has been used, so there is still some things open. Exactly, but that's the workflow on how to log in. Now, any questions on that, or is it pretty clear on how to log in? I guess so. Perfect, yeah, good. Okay, then we go back to our or to my platform lab. I think I have already one open, so I will use that one. Just give me a second on opening that again. No, this is the wrong one. Okay, I think, let me see. This should be here. Just a second. I got this open somewhere. No, this is not the right one. This is the right one here. Okay, so I created an OpenEO platform C-scale training where you will find two notebooks. The first one is actually an OpenEO Force notebook. So basically, what you can do with OpenEO platform is you can run the Force workflow. I hope all of you are aware of what this is. Otherwise, I will share a link really quick.
Could you also increase a little bit the font, Benjamin?
Oh yeah, sure. No worries.
Thank you.
130 is enough, or?
Yeah, that's fine.
Cool. Perfect. So for Force, really quickly said, is a workflow to generate analysis-ready data from level 1C. So here you can use the Force workflow for an area of interest, and in the background, the Force workflow will return the requested bands in the end. And I ran this actually in another notebook already, but I'm going to show you the first, or actually let's go through that one. So what you do in the end, you import OpenEO. It's always good to actually check the client version. So I will add another cell here. And the latest version is actually 13.0. In development, it's 13.1 at the moment. What you do then is you authenticate with the backend, or actually with the federation layer. We call it aggregator, and I'm seeing here now a line authenticated using refresh token. Another option would be that you see a line basically saying, please authenticate with a device login, and then you need to copy a string that is that has 9 digits, and you need to go to a website and enter these 9 digits, and then you are authenticated. Here we define a spatial extent and a temporal extent for our first workflow. So in the end, what we want to do is we want to run force over the month of January 2021 on the level 1C collection. So in the end, if you go here to data collections, that's another representation of the available collections. And if you search here for Sentinel-1, then you will find certain Sentinel-1, Sentinel-2. We're going to run this on Sentinel-2 level 1C exactly. So you can find several Sentinel-2 options. So for instance, here, I think this is the Sentinel-2 level 1C that we will be using. Other providers have, so for instance, the Sentinel Hub will also be exposing this. But for now, we will be using that Sentinel-1 level 1C collection. Exactly. And there you define basically your data cube. So with a load collection call, you say, okay, I want to define this collection. I want to define this spatial and temporal extent, and I want to define, or I want to use all the bands for my atmospheric correction. Exactly. And then the process to call this force workflow is ARD surface, is called ARD surface reflection. You have to give the method force into there, and then also the cloud detection mask. Now I'm going to show you where you can all find this. So basically, if we go back to the processing capabilities here, you can also search here, and you can say ARD, and then you find here the options on how to actually do this. Currently, this is in an experimental state. I mean, on the other hand, we have updated this, so you should be able to use this quite stably right now. We are just updating now from force 3.6 to 3.7 in our dev backend. So this should be running next week, the newest force workflow. All right, so we have now, and then in the end, what we are doing after this ARD surface reflectance, in the end, we will be doing a save result call. So we define the format of the save result, and then you can basically save your data firstly on the backend, and then secondly, you can download it to where you need it to. So here, I'm going to create a job. Actually, this is also a nice representation. So the key, or what you need to know here, is that and this is how it actually works, is the language works in this JSON language in the end. So this JSON language is transferred to an endpoint of the backend, and then the backend knows basically the recipe that you have defined just in this cell up here. So when I flap the graph here, then you can actually see that I am basically having defined this recipe for the backend, and then the backend knows, okay, this is, I need to load this collection, I need to run this on this collection, and then I can save it into netcdf. Exactly. So that's the key to know. And then I'm creating the job. And once the job is created, it gets a unique ID. And this unique ID, then exactly, you can refer always back to it. So as long as the backend hosts this job, you can also get back the results. So at the moment, we are currently in the definition phase, but for EODC, at the moment, we don't delete any jobs yet. But for the other backends, they are currently after 90 days deleting the results and the jobs. So after 90 days, you currently don't have any access to the results anymore. Exactly. So, oh, I forgot to run the cell above. So here I'm starting my job, I think. Did I start the job already? Let me just see, where did I start the job? Okay, I think I forgot a line here. Let me quickly see. Yeah, the job is created but not started. So let me quickly grab this from another file. I think it's underscore, but I need to double check. Yeah. So created, so it should be started now. And maybe I do only 2 seconds, then I have a feedback of 2 seconds. Yeah, exactly. So now I wrote this while loop here just to get informed, basically. So what is this job status? There are 4 states available. That is queued, created, queued, running, finished, and the last one would be error. So if you have an error, then the job is finished. So right now, the EODC backend is doing its job in basically running the ARD surface reflectance over this area. And while the EODC backend is doing its job, I'm going to stop querying it actually every 2 seconds. I'm going to go up to a minute, and then we can have a look at it later. So what you have seen now here is that I created an asynchronous job. So in the end, the EODC backend runs now this force workflow basically and on a scheduled manner, right? So if the backend is very busy and no pods, no Kubernetes pods are available, then you would need to wait a bit longer to finish your job. But OpenEO offers also the possibility for synchronous jobs. That means if an area of interest is very small and you just want to grab quickly results, you can also run synchronous jobs. And I'm going to use here the this is an NDVI, a very simple analysis, an NDVI time series analysis, but I think it beautifully shows that you also can use it for an ad hoc manner, quick analysis. So what I'm doing here is, and I don't know if this runs now because I think I don't have that potato field. Probably need to do, I authenticated already, exactly. So what I'm using here is the Sentinel-2 level 2A collection, similarly as before, but this time, not similarly, a different collection, but the temporal extent I'm using over almost 2 years. 1 year, 4 months, sorry. And the bands, I'm just using band 4 and band 8 and a cloud mask. So therefore, I can just simply mask the Sentinel-2 collection for the respective clouds directly. What we can see here is what we will do. So in the end, you can see that different types of vegetation have different signals in the NDVI. So what we are doing here is we are gonna run the analysis based on this, or based on a potato field that we know is potato, and then get the signature of this potato field from that. And that, since that is very small, yeah, exactly, that was not a problem. I just need to fetch another Jupyter Lab where I have this file available. Sorry for that. Just quick. No, it's not this one. It's not this one. Sorry. Takes a minute. Actually, I should have it. No, it's not in here. Ah, it's in here actually. Exactly. Copy. So I'm gonna copy the potato fields. Exactly, now it should be available. No, it's not. Ah, it's actually missing also the maze. So everything else. Copy. Any questions in between? Please go ahead. All right, now I got my GeoJSONs from these different serials available, and I know one of these fields is a potato field, and I get the field geometry, and basically what I'm doing here now, I'm computing an NDVI indice. This is very specific for the Python client, because in the Python client there's some Pythonic functions available that you can use to actually compute, for instance, these indices more easy. But you could also basically say, okay, I want this S2 masks and then masked, and then write a dot NDVI after it. That would be also possible. But it's all documented in the Python client, so very obvious. So right now here, what I'm doing is I'm defining another process graph, and since that process graph is very small, I can, or the area of interest is very small, I can just directly tell the backend, hey, I know this is very small, so please run directly this and download me the time series from, or aggregate over this potato field and download me the mean of the pixels and the standard deviation of the pixels. This should run about within a minute or so. So you can actually then get the NDVI time series of your potato field. Back to our fourth job, it's still running. So actually what I can show you now in the meantime is the great thing about OpenEO is now when I open up the editor, is that my jobs that are running on the backend are actually available in any other client. That means if the editor opens, I actually have the jobs that are currently, that I scheduled on the backends are currently available. Obviously, except for these synchronous jobs, because they are directly available. So you can see the wall time was about 1 minute 20, and now I have this NDVI time series from the potato field available. Down here, there's just a simple other analysis. I won't go into detail here. All right. Let's try again. Now it works. All right. I'm signing in through EGI check-in again. Exactly. And now on the lower part here, you can see actually that, for instance, this force job here that I'm running is actually running. And you can also see a representation, this drag and drop representation. The great thing about the editor is also I can also grab any other job that I ran before, and I can actually also export it. Now I have to see exactly. I can export it to another programming language. So for this job, it might not be available, but for another job, it might be available. This is still under development, so it might not fully work, but now you can see here is the JavaScript representation, here's the Python representation, and here's the R representation of this job. Exactly. All right, maybe the last 10 minutes we can use if there are no questions. Maybe the last 10 minutes we can use to actually divide the test users. I'll stop sharing for a minute, and basically maybe we can just simply I will write a couple of test users in here, and then I just need an email address with those test users so that you don't use too many test users together and so on. And then after the training, I will just simply write you an email with the password to the test user. So yeah, maybe raise your hand really quick. so I can provide you a test user. And Sebastian, I think we can stop the recording here, huh? I guess.
Okay, let's do that then. Thank you.
Okay.